Hey there, nice to have you again. Welcome back to O3 Schools channel. All right, and of course, today we're going to continue our teaching on alkanes. Okay, today we're going to be looking at the IUPAC nomenclature, IUPAC nomenclature of alkanes. Okay, we're going to be looking at the IUPAC nomenclature of alkanes. All right, my name is Master T, and I am the commander of this great army. All right, if you are a soldier under this army, then of course, success is within your grasp. It's just for you to reach out and get it. All right, so please do not forget that this tutorial is brought to you by the O3 Schools Jamb app. It is all you need to succeed in your exam. If you want to succeed and not succeeds, please jump on the app immediately and start practicing your way to success. So I'm going to talk about the app later, but let us see a question from the O3 Schools Jamb app pertaining to what? IUPAC nomenclature of alkanes. This is a 2021 question, number 21. Okay, and it is body written here. Okay, it's shown on the what screen? It's been shown on the screen right now, but let me just bring it out. All right, so we're given a compound, and then there's a methyl group here, and then we're told to what? To name. Okay, what is the name of what this compound? So use the structure below to answer this question. So what is the IUPAC name of the compound with this what structure? Okay, so this is what we are going to be talking about what in this class. Okay, we're going to be looking at the IUPAC nomenclature of alkanes. If you understand the IUPAC nomenclature of alkanes, we move into IUPAC nomenclature of alkenes, move into IUPAC nomenclature of alkynes. All right, then what naming any compound in organic chemistry, if you know your homologous series very well, will be very, very easy for you. So what I'm going to do, I'm not going to answer this question now. I want to come back at the end of the class to answer this question and more questions on what on this topic. All right, so please stick back, make sure what you stay to the end. All right, and make sure you go to Play Store immediately and download the O3 Schools Jamb app. It has all the past questions you need to succeed in your exam. It has what question search feature where you can search for question according to topic. It has the UTME mock challenge that will conduct for students that are writing Jamb for a particular year every Saturday. Every Saturday you sit down in front of real Jamb questions. Okay, to what to answer, get used to Jamb past question, build your confidence toward the exam. We release your results every Saturday too. Then you're able to what to see your score. Imagine your score improving after every challenge. You see that what you build your confidence toward the main exam. Do not sleep on the app. There are many testimonies from this app. Go and check our testimonies on the channel, and you'll be amazed at how this channel has helped a lot of students, and your case will not be different. All right, let us leave too much talk and talk about the IUPAC nomenclature of alkanes. So basically, first of all, what is even IUPAC? Okay, if this is your first time of hearing IUPAC, I think this is a past question on Jamb. Okay, so just search for IUPAC using the question search feature on O3 Schools Jamb app. You will see that what a question will be asked, the full meaning of IUPAC. IUPAC is International Union of Pure and Applied chemistry. Okay, so that is what IUPAC, that's the full meaning of IUPAC. Okay, IUPAC is International Union of Pure and Applied chemistry. It is an international organization that is in charge of chemistry and other related technologies. Okay, so please take note of that. IUPAC nomenclature of alkanes. All right, so now we name alkanes. We can name alkanes using some trivia names. Okay, all right. Why some with what the IUPAC name? In one of the previous episodes, we have looked at the first 20 alkanes. Okay, so but for here, we are not going to be considering the first 10 alkanes to make us understand this topic clearer. All right. So the first alkane we have is methane. Okay, we know the general formula CnH2n plus 2. CnH2n plus 2. This is the general formula for alkanes, right? Okay, so now we have methane, then we have ethane. Okay, then we have after ethane, we have propane. After propane, we have butane. And if you see these first four, okay, they are trivia. Their names are are trivia. Okay, but from the fifth one, pentane, okay, is gotten from From pent. From pent. Pent means 5. Okay, the next one is is hexane from X. Okay, then we have heptane. Then we have octane. We have nonane. and then we have the cane. Okay, so these are the first 10 what alkenes. Okay, so now, also, when an alkane loses what an hydrogen atom, it forms what we call an alkyl group. An alkyl group. Okay, so when an alkane loses one hydrogen atom, it forms an alkyl group. Take note of that. For example, methane. If methane loses one hydrogen atom, methane is what? CH4. If it loses one hydrogen atom, it will be what? CH3. Okay, so instead of now methane, okay, that is CH4, this one that has lost one hydrogen atom is now called what? Methyl. Okay, so it's what now forms what we now add what the YL, remove the ANE and just put what YL. All right, so this is what a methyl group. This is an alkyl group. It happens, or alkyl groups are formed when what an alkane loses one hydrogen atom. So methane will lose one hydrogen atom to CH3 and to now become methyl. Okay, YL. So for example, if an ethane loses one hydrogen atom, instead of C2H6, it is now what? C2H5. Okay, and C2H5 will now be what now? Ethyl. Okay, also for propane, if it loses one hydrogen atom, propane is what? C3H8. Okay, if propane loses what? One hydrogen atom becomes what? Propyl. So please take note of that. That is how what alkyl groups are formed. I think it's in one of the questions we are going to what consider at the end of the class. All right, so please, all these things are important. They are not necessary. I will have told you so. That is why I am the commander of this army. All right. So if they were not important, I will not be saying them. So please take them to heart and commit them to memory. All right. Then of course, under the trivial system, we know that what a straight chain hydrocarbon, a straight chain hydrocarbon is called a normal compound. It's called a normal compound. Okay, a straight chain hydrocarbon is called what? A normal compound. So that's why you may hear under the course of what this study, where we can say what? N-octane, okay, or N-heptane. Okay, that's what? Normal octane, normal heptane. Okay, this is straight chain what? Hydrocarbon. Okay, if octane has how many carbon atoms? 8 carbon atoms. So a normal octane will be what? C. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. 1, 2. We are doing that challenge. Okay, but let's just come back to the class. So now this is what a normal octane, because it has what? It's a straight chain what? Hydrocarbon having what? 8 carbon atoms. Okay, so you can now put HH here to fill it up. HH, H here, you will write H, you will tire. Okay, so this is what? This is a normal what? Octane. It's a straight chain what? Hydrocarbon. Okay, so now please, instead of writing this C like this in this straight chain, sometimes we have what? The condensed form. After the condensed form, we now have the stick form also. Alright, in the course of this class, I'm going to be using more of the stick form to explain to you. So please understand. But if you want to condense this, of you to write, see, what if you now have 20? Okay, then I say we should write the structure of icosane now. As icosane has 20 carbon atoms. So that means this body may not even be enough for to write the structure of icosane. So that is why we can what? We can represent this structure in a condensed form. Instead of this drawing all this in, we can just what? Break it down to what? CH3. How many hydrogen atoms are linking to this carbon atom? 3. So you can say CH3. Then this one now, CH2. Then this one, CH2. This one also, CH2. This one, CH2. This one, CH2. This one, CH2. Then this last one, CH3. So this one, yeah, this is a condensed form. Say condensed. It's in the condensed form. Okay, so now this is also the same thing as this, no difference. Okay, please take note of that. So instead of writing this, you may see this. Okay, but this is still normal what? This is still normal what? Octane. Okay, it's a straight chain what? Hydrocarbon. Also, we can also represent them using stick form. In that stick form, I want to come back to this place. So in that stick form, every bend and every end is a carbon atom. Stick form. The normal stick, stick form. In this stick form, every bend is a carbon atom, where every end every end, okay, and every bend is a carbon what atom. So for like this normal octane now, okay, we can present it like this. One, there's a carbon atom here. This is an end. This is what still bend. Okay, this is a carbon atom here. There's 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 a carbon atom here. 1, 2, 3, 4, 5, 6, 7, 8. 7, 8. So this is what? Normal what? Octane. Okay? This is a straight chain hydrocarbon, but it is representing in what? In a stick form. So do not be confused. Alright? So this first C is what I see here. This next one is what I see here. This next one is what I see here. This next one is what I see here. And so like that, like that, like that. So take note of what this stick form is very, very, very easy to what? To understand. Okay? There's no much what difference than the normal one we first drew, this condensed form and this stick form. They're all what the same representation. Okay? Every end, every bend, carbon atom, they there. Stick form, very, very easy. All right, so now let us now come back to, please take this to heart because this is what I'm going to be using in this class. This stick form, I'm going to be using it a lot in this class to make us what? And make our work easier because I cannot just be drawing structures and drawing long structures like that on the board. That will make it very easier for us. Okay, now, so this normal compound, we say a straight chain hydrocarbon is called what? A normal what compound or a straight chain alkane. Okay, a straight chain alkane, a straight chain alkane. Alkane, okay, it's called what? A normal compound. Then a branched chain alkane. A branched chain alkane is called what? An iso compound. Okay, so that instead of what having normal octane, this. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, instead of having this, okay, we can also have what? A branched chain what? I can have an isomer of what? Of this what? Of this normal octane. Okay, an isomer will now have what? We have a methyl group. So instead of what? This group now, maybe somewhere you can now have pentane 1, 2, 3, 4, 5. Okay, and then these ones will now be what? These 3 carbons will now be what? They will not be alkyl groups. Okay, maybe on this, maybe there will be CH3 here. Maybe there will be CH3 here. Maybe there will be CH3 here. Okay? So that here now we're not going to have what? There's a methyl group here. There's a methyl group here. Alright? So this will now be what now? 1. If you number 1, sorry, I'm going to come to what? Understand. I'm just trying to what? Make you what? Understand. So what I mean by a branched chain alkane. Okay? So instead of having that long chain, we can now what? Break those groups. Okay? And then we now have what? Methyl groups. Okay, so now let us not waste our time on this. But basically, this will now be what now? 1, 2, 3, 4, 5. If you number like this, okay. So now I'm going to have 2, 3, 4. That's 2, 3, 4 trimethylpentane. Okay, so now this is what? This is what? This is a branched chain what? Hydrocarbon. It's a branched chain what? Hydrocarbon. Okay, so the branched chain hydrocarbons like this are called what? Iso compounds. Okay, now let us now go to the last one. An alkane that has a central carbon. An alkane, this is under the trivial system of naming what? Alkanes. Okay, an alkane with a central carbon atom, okay, with the central carbon is called a neo compound. Is called a neo compound. An alkane that has a central carbon is called what? A neo compound. So these are all under what? The trivial system of what? Of naming what? Alkanes. But what we are here for really is the IUPAC, the internationally recognized system of what? Of naming what? Compounds. Okay, so let's go to IUPAC nomenclature proper. Let's go to IUPAC nomenclature proper. All right, so let us begin with a simple example. Let's say this first example, we have something like this. 1, 2, 3, 4, 5, 6. Okay, so this, of course, you know, this is the stick form. Okay, we're going to use stick form to what? To make us what? Understand this. It's very easy. So just follow along. Okay, we said in this stick form, every end and every bend is a carbon atom. That means what? There's a carbon atom here 1. There's another carbon atom here 2. There's another carbon atom here 3. There's another carbon atom here 4. There's another carbon atom here 5. There's another carbon atom here 6. Okay, so this means that what? You can number. We number. We want to name what? Name a structure. We number. Okay, we have 2, 3, 4, 5, 6. Okay, so now which alkane has 6 carbon atoms? Okay, so first of all, the first thing that we'll do when we are naming alkanes is to identify the number of carbon atoms in the parent chain. Okay, the first thing to do is to identify the number of carbon atoms in the parent chain. Some people will say, well, the longest continuous chain of what? Of carbon atoms is also what? The same thing. Okay, so identify the number of carbon atoms in the parent chain. Okay, or identify the largest continuous chain of what? Of carbon atom. Okay, so this is a chain 1, 2, 3, 4, 5, 6. Okay, so we have 6 carbon atoms. Then of course you now say, which name do we give to an alkane, or do we give to an alkane, or do we give to an alkyne that has 6 carbon atoms? Okay, so an alkane that has 6 carbon atoms, okay, is what? Definitely what? Hexane. Okay, that means it's going to be what? Hexane. Now you ask yourself, is there any substituent attached to this structure? No, there's no substituents attached to this structure. So it's just a straight chain what? Alkane. It's a normal compound. So this will be called what? An hexane. Okay, so this is what in this one now, to solve this one, what we just used, we just identified the number of carbon atom that is present in the what? In the parent chain. And then it made us to what? To know the name I'm going to what? Give to this what? Compound. Okay, so now let us metamorphose into gear 2. Okay, let's say we have another example. Let's say we have this, but this time we have, for example, a substituent. Okay, we have a substituent, number 2. Let's say we now have what? A substituent. 1, 2, 3, 4, 5. Okay, so let's say we have a substituent on this second what? On this second carbon. Okay, so now this is the stick form. It's also very, very easy. Okay, so now this is the first step we're still going to do that identify the number of carbon atoms in the parent chain, or the longest continuous chain of carbon atoms. Okay, so now number 1 here, this is 1. If you number, this is 2, this is 3, this is 4, this is 5. Okay, now remember that when you are numbering, you can number from this side. You can start numbering from left to right, or from right to left. So that means you could also do like this. Okay, and now number 1, 2, 3, 4, 5. Okay, they will not kill you for doing it. Okay, but which one will be the right one? Okay, if we name this compound, we will see here that there's a what? You know that every end and every bend is a carbon atom. That means there's a carbon atom here. Okay, so there's a substituent that has been attached to this word, to this structure. Okay, so now that is why I talk to you about alkyl groups. Okay, we say alkyl groups are formed when what? An alkane loses what? 1 hydrogen what? Atom. Okay, so that means that what? Here now a substituent has been attached. It means what? It will be what? An alkyl group. And now which alkane has what? 1 carbon atom? That is what? Methane. Okay, a methane that loses 1 hydrogen atom will be what? Will be methyl. All right, so now it becomes very easy for us that we know that what? There's a methyl group. Okay, there's a methyl group or substituent that has been attached to this what? To this structure. So also this methyl group is what? Is here. Now let us name this compound. So on which of the carbon atom is this methyl group attached? On the second carbon. All right, so now we'll say 2-methyl. Okay, we use what? Hyphen. We use hyphen to separate numbers from letters when we are what? Naming what? Organic or compounds. Okay, we use a hyphen to separate numbers from letters. Okay, so we'll say that what? 2-methyl. Now how many carbons are in the what? In the parent chain? 5 carbons. 1, 2, 3, 4, 5. And which alkane has 5 carbons? That is what? Pentane. So we know that this is a pentane. So this will be what? 2-methyl pentane. Abi, very simple. Now let us name this one. We know I have told you rather that you have the liberty of numbering from left to right or from right to left. Okay, now let us name this one. So this one will be what? This methyl group here now is on the 4th carbon atom. So I'm going to have what? 4-methyl, the same word, pentane. But which one is more correct? Okay, so when we have in this kind of crossroad, we take the number that is lesser. Okay, we cannot take the number that is higher. We take the number that is what? That is lesser when we are naming. All right. So now the substituent is on the second carbon on this one, but the substituent is on the fourth carbon on this one. That's why this one cannot be the correct answer. This will be wrong. If you see the question we saw before we began this class, okay, we are giving a question. You see this option. You see, if you are given the kind of question in an exam condition, you see this option, you see this option. So this one is wrong because it has what? The number, the substituent is now on what? On the higher number, but this one is on the lower number. That's why this one will be the correct name for this compound. That will have what? 2-methyl pentane, not 4-methyl what? Pentane. So you number so that the substituent has what? A lower number. Or when you are naming, you make sure that you pick the number with a lower what? A number that are what? That are lower. Okay. So instead of, let's say for example, we have 2,2 and we have 2,5. Okay, sorry, we have now 5,6. Instead of this 5,6, you take what? 2,2. All right, because this 2,2 is what? Is smaller. All right, now let us now metamorphose again. So we identify the what? The number of what? Of carbon atoms in the parent chain to be pentane. Then we identify the carbon on which what? The methyl group has been attached, or the alkyl group has been attached. That made us to know the number we are attached to the what? To the methyl group. So 2-methyl pentane. Very easy. Yeah, being no easy. I don't say easy. So now let us metamorphose. Let us go to another example. So let's say now we have what? Another structure. Another structure. And we now have something like this. 1, 2, 3, 4, 5, 6. Then on this case, we have what? A group here. Then on this side, we also have a group here. Okay, now this becomes very easy. So first thing, identify the number of carbon atoms in the parent chain. So here you have 1, here 2, you have 3, you have 4, you have 5, you have 6. Remember, you have the liberty of naming. Okay, of what? Of numbering. So you can also draw this structure somewhere here. Okay, and then you now say what? 1. There's a group here. There's a group here. This will not be 1. This is 1. This will be 2. This will be 3. This will be 4. This will be 5. This will be 6. Okay, so now we have numbered. Now we have what? A methyl group here. Because there's only one end here. There's one carbon atom here. There's one carbon atom. That means that this is a methyl group. This is a methyl group, and this is also a methyl group. Okay, so same as this and this. Now come to our numbering. Identify the what? Number of carbon atoms in the parent chain. 6 carbon. 6 carbon corresponds to what now? Hexane. We already know that this is an hexane. All right. So now what do? The methyl group is on what? On the second carbon here. So we have what? 2. Okay. Instead of saying 2-methyl, then we now say what? 3-methyl again. Okay. So instead of saying 2-methyl, 3-methyl, instead of this repetition, we introduce what? Prefixes. Okay. We call them prefixes. Instead of all doing this repetition, 2-methyl, because there's a methyl group on the second carbon, there's a methyl group on the third carbon also. All right. So instead of saying 2-methyl, 3-methyl hexane, okay, we can now say what? Since we have 2 methyl groups, we now put what? Di. Okay, dimethyl, 2,3-dimethyl. Okay. So now that means the correct naming here will be what now? 2, you use what? Comma to what? To represent, to what? To separate numbers from numbers. The first methyl is on the second carbon, so 2. Then the second methyl is on the third carbon, so 2, 3. How many methyl groups do we have? Dimethyl, what now? Hexane. All right, so this becomes very, very what? Easy. All right, now let us name this one too. So here now will be what now? 4, 5-dimethyl hexane. Okay, so hope you understand why it's 4, 5. Okay, because the methyl group here, when we number from right to left, okay, it's on the 4th carbon and on the 5th carbon. So now we're going to have 4, 5-dimethyl hexane. All right, now which one should we pick? 2 and 3 and 4 and 5. Which one is lesser? 2 and 3. 2 plus 3 is 5. 4 plus 5 is 9. Okay, take the lower word number. Okay, so 2 and 3 is more correct. So we're going to what? Take 2, 3, 2, 3. Remember, sorry, we use hyphen to separate letters from numbers. So we use comma to separate numbers from number. We use hyphen to separate letters from number. Okay, so I'm going to have 2, 3 dimethyl hexane. Are we ready to metamorphose to another higher grade? Okay, so now let us have another example. This will be the 4th example, I guess. Yes, this will be the fourth example. So let's say we also have what this 1, 2, 3, 4, 5, 6. Okay, and then on this carbon atom we have what? We have two branches like this. Okay, and then likewise here we have this. Now, how do we name this compound? Okay, remember I told you that every end, okay, and every bend is a carbon atom. Okay, but now you can see that there are two methyl groups that has been attached to this carbon here. Okay, let us first of all identify the number of carbon atoms in the parent chain. This is 1, 2, 3, 4, 5, 6. When we're talking about naming alkanes, I'm not going to stress myself too much. So understand this very well here. We are metamorphosing to alkanes. I'm not going to spend so much time like this. We'll be breezing past it. Okay, so this is just the beginning. I want you to fully understand it so that when we get there, it becomes very easy. See now, my throat is dry. Just because of you, and you not like this video. Are you not wicked? Just like this video and share to your friends and loved ones. All right, now let's name this. Okay, so now we're going to have what now? There's a methyl group here. There's a what? A methyl group here. This is also methyl. This is methyl. Okay, please, when it comes to this stick form, like this is different from what? Like this. Because look at it now like this. Then look at it like this. Okay, so this is an attachment. Okay, but it's one what? Atom. It's one group. But this one now is a separate group because this one goes here, this one goes here. So this is the same group. This is separate what group. That's why I have methyl here, I have methyl here. But if this one now, this will be what? A carbon atom here, carbon atom. That will be what? C2H5. That's one what? Ethyl. Okay, so please take note of that. Or if you now have something like this, okay, it's still one group. Okay, one group. There's a carbon atom here, there's a carbon atom here, there's a carbon atom here. This will be what? Propyl. Okay, so please take note of that. But this is separate because you can see they are going in different direction. There's no continuity with them. All right, so let us now name this compound. Remember, we can also decide to draw the structure again to make us see the beauty of naming it. Okay, so we have group here, we have group here. Okay, this will be 1, this will be 2, this will be 3, this will be 4, this will be 5, this will be 6. So already 5 and 4. You should already know that this one cannot be right. Okay, so we will not bother about naming this one. This will be our correct numbering. Okay, so now let us go. So there's a methyl group on the second carbon. So it will be what now? 2, there's a methyl group on the third carbon. There's a methyl group also again on the third carbon. So I'm going to have 2, 3, 3 hyphen trimethyl. Because there are 3 methyl groups, okay? Trimethyl what now? Is it hexane? Yes, hexane because we have 6 carbon atom. Hexane. So this is very, very easy, right? Very, very easy. Okay, now we metamorphose also again. So another example. This will be the 5th example. If you understand what I've been doing so far, there's no alkane you cannot name. All right? There's no alkane you cannot name. All right, so now number 5. Let us now say we have something like this. 1, 2, 3, 4, 5, 6, 7. And then here we have what? A propyl group. Then here we have what? An ethane group. Okay, a methyl group rather. All right, so now let us identify the longest chain of continuous carbon atoms or the number of carbon atoms in the parent chain. We number here 1, 2, here 3, here 4, here 5, here 6, here 7. If you number the other way, here will be 1, 2, 3, 4, 5, 6, 7. So instead of 5 and 6, we're going to have 2 and 3. So definitely know that numbering from left to right will be more correct than numbering from right to left. Okay, so we have that. Let us name it. So here now there's a propyl group because what you can see here is a carbon atom. It's not propyl rather, ethyl group, 2 carbon atoms, right? There's an ethyl group here. Then why here there's a methyl group. So now let us name it. So I'm going to have what now? The ethyl group is on the On the second carbon. That will be 2 ethyl. Okay? 3 methyl. How many carbon atoms? 7. That will be now? Heptane. Okay? So I'll be able to name this compound to be 2 ethyl, 3 methyl, heptane. Now, what about if we now say another person now comes and say 3 methyl? Okay? We now say what now? 3 methyl, 2 is it 2-ethyl? Then 2-ethyl heptane. It's the same one here, the same thing here, but we are now bringing methyl first before what? Ethyl. Now, which one do you think is more correct here? Should I give you time to think? All right, think for 1 minute. All right, your 1 minute is over. So, which one do you think will be more correct? The more correct what naming will be what? Will be this. Okay, so in this case now, what we do is that we alphabetize. Okay, this is what we do in this condition. We what? We alphabetize. So that means that what? The alphabet that comes first, the smaller alphabet will come first when we are naming. We will give credence, we give what? Preference to the alphabet that is smaller. Okay, before what? The other what? Alphabet that is larger. So now, look at the beginning of what? This. Ethyl is E. Methyl is M. M is bigger than what? E. So 2-ethyl is more what? Appropriate. Okay? 2-ethyl is more appropriate than what? Than 3-methyl. Okay? Because what? E comes before what? M. So 2-ethyl, 3-methyl heptane will be correct. This will be what? This will be wrong. Okay? This will be wrong. Alright, so please, this is IUPAC nomenclature. So you must what? Take note of that. I'm giving you these several examples so that what? You can be fully cooked when it comes to what? Naming what? Organic compounds, especially what? Alkanes as we're looking today. So let us see another example. This will be the penultimate example, number 6. All right. So now number 6. Okay, we have what? 1, 2, 3, 4, 5, 6, 7. Okay, that's an heptane. Then here, let's say we have okay, then here we have a propyl group. Okay, now let's just say we number. Let us find the number of carbon atoms in the parent chain. Here will be 1, here will be 2, here will be 3, here will be 4, here will be 5, here will be 6, here will be 7. Okay, so the number of carbon atoms in this chain is what? Is 7. So definitely we already know that is what? That is an heptane. Now let us now name it. Here we have what? How many carbon atoms? Carbon atom here, carbon atom here, carbon atom here. So that is what? C3H7, which is what? Propyl or propyl. Some people say it's propyl, some people say it's propyl. Okay, anyone you say, provided you know what you are doing. Okay, so this is a propyl group. Why here? How many carbon atoms here? C, 2 carbon atoms. This is what? An ethyl group. Okay, so that means naming it will not become a problem any longer. But now, the ethyl group is on what? The propyl group is on the what? It's on the second carbon. So I'm going to say 2-propyl. Okay, then we're now going to have what? Is it 5? 5 what now? 5 what? Ethyl heptane. Okay, so now let us now see. Let us also number again to see from the other side. If you number from the other side from right to left, here will be 1, here will be 2, here will be 3, here will be 4, here will be 5, here will be 6, here will be 7. Okay, let me take all this one off. So if I number from the other side, I'm going to have what now? First of all, 3-ethyl. 3-ethyl, right? Then I'm going to have what here now? How many propyl? I'm going to have what now? 6-propyl. Okay, now how about heptane? All right, so now which one do you think will be what? Will be more correct? Should you number from left to right or from right to left? This one is 2 and 5. This one is 3 and 6. 3 plus 6 is 9. 2 plus 5 is what? Is 7. So first of all, this one is what? Is wrong. Now, but do we say 2-propyl or we say 5-ethyl first? Now, that will now be the other part for us to take note of. So, since first of all, when it comes to numbering, we have written this one off. Now, we'll now come to what? Alphabet. Okay, what begins the alphabet is what? Is P and E. So, we are considering P and what? And E. Should ethyl come before propyl? Yes. Okay, so that means that what? This naming is also wrong. We have to what? Rewrite it to be what? 5-ethyl. Okay, 5-ethyl. Then 2-propyl or propyl heptane. So this will be the correct naming for what? For this compound. Is that all right? Please, now I'm going to now take what? The last example. All right, let's see the last example. The last example, and we are done with the IUPAC Nomenclature of Alkanes. Then we'll take questions from the O3 School Jamb app. So please like this video, subscribe to this channel, and share. Make sure you share. Don't be wicked. Okay, only wicked person go see this kind of good thing, go keep on to himself. click on that share button now. But do not forget to subscribe. Click on that red subscribe button if you have not subscribed before. But if you have, thank you and God bless you. Let's see the last example, number 7 now. So let's say we have something like this. Okay, 1, 2, 3, 4, 5, 6. Okay, let's say here we have something like this, then here we have something like this. Okay, so now let us identify the number of carbon atoms on the parent chain. 1, 2, 3, 4, 5, 6. We already know this is what? An hexane. Then what group is here? We have what? A methyl group here. We also have another methyl group here. Then this one is what? Is ethyl. Okay, because this is CC. 2 carbon atoms. That is what? An ethyl group. So if we want to name this compound, how do we begin? Okay, so here we have what? There's 2 methyl group on this second carbon. So I'm going to have 2, 2 dimethyl. Abi? Okay, then we're going to have what now? 4 what? Ethyl hexane. Okay, so now that will be the way we name it. But are we correct? Are we wrong? Okay, should we what? Is there something we need to what? Check here to be sure that we are right or wrong? Yes, we have to what? Take into cognizance. Okay, the what? The alphabet. The alphabet that began here is what? Is D. This one that began here is what? Is E. Should D come before E? Now, I need to now tell you the secret. When we are alphabetizing, okay, if you are using alphabet, okay, we do not consider prefix. This die no concern your papa when you are naming them. This die, this prefix here does not concern the naming. Wait till you go look. Now this M and this E. Okay, so it is this M and E that you take into account of. All right, so now let us now see. That means that what? M and E, which one should come first? E should come first. So 4 ethyl should come before 2 dimethyl. Okay, because we are not considering this prefix. Okay, we don't consider prefix. We do not consider what prefix. We are trying to what? Check what alphabet. So this prefix, we're considering that it's not there now. I'm going to have what now? 4 ethyl. Okay, then 2, 2 dimethyl hexane. So this will be what the correct what name for this what compound. All right. So please, I'm sure with this knowledge, there's no compound you cannot what name. Let us jump to the O3 School Jamb app. Like I said, go to Play Store, download it. The activation fee is just a little amount. Pay the sacrifice, activate it, start practicing. You don't have time to wait for anybody. All right. So 2021, number 21. What will be the correct answer there? If you number that compound, okay. If you number that compound, it's just like we're having, this is C, 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 C. Okay, there's a methyl group here. It's just like we're writing stick form. Okay, 1, 2, 3, 4. Okay, this time say this one no join. Stick form. Then on the second carbon, 1, 2. On this second carbon, there's a methyl group. Okay, that means there's one water arrow here. Okay, so this is 2, 3, 4. This is in stick form. This is not easier to don't do y. Okay, so what drawing H here now. You get it. So stick form is quite what easy and interesting. But right now, so how do you name this compound? The methyl group is on what? On the second carbon. Remember, this is methyl from CH4. When it has lost one hydrogen atom to what? To methyl. So this will be what now? 2 methyl. How many carbon atoms are in the parent chain? 4. That is what? Butane. Okay, that's about 2 methyl butane. Okay, so now let us see. Option A say 3 methyl butane. B 3 methyl pentane. Okay, for C 2 methyl butane. D 2 methyl propane. So our correct answer will be what? Option C 2 methyl butane. Okay, remember I can also name this compound from here 1, 2, 3, 4. If you number from this left to right, I'm going to have what? 3 methyl butane. Okay, but in that case 3 will be bigger than what? Than 2. That's why we'll pick what? 2. Because 2 is what is the shortest what number to the substituent that has been attached to the structure. Okay, so please understand what you have been doing and enjoy yourself. Now, there's another question here. They say this is a 2023 question. This is a 2023 question, number 30. 2023, question number 30. They say, how are alkyl groups named in organic chemistry? Alkyl groups, we talked about that. We say alkyl groups are formed when an alkane loses an hydrogen atom. Okay, so that is what happens. So, but what do we add? What suffix do we add? We add what? YL. Okay, so BA say by adding the suffix "in" to the name of the parent alkane. B, by adding the suffix YL to the name of the parent alkane. C, by adding the prefix ALK to the name of the parent alkane. D, by adding prefix alkyl to the name of. The correct answer there is what? Adding what? YL. That is what our option what? Option B. So you see that you are jamming and enjoying jam question because you know what you are doing. Okay, so please. This way I'm going to stop under this episode. In the next episode, we're going to be looking at the uses of alkane, and then we'll do a complete summary of what of alkanes and we'll move to the alkenes. Okay, thank you for watching. Thank you for staying with your commander as a soldier. Keep studying and keep being cheerful. Enjoy yourself. I'll see you in the next episode.